Now, when we have any kind of function in the integrand, if the lower limit and the upper limit is equal to each other, then I can conclude that this thing is equal to 0. So let's do something for fun. Today we are going to solve the integral of inverse cosine of x dx, where x goes from -1 to +1 in 4 ways. Now let's get started. So the first method is to solve the integral of inverse cosine of x using integration by parts. So how are we going to use integration by parts to solve the integral of inverse cosine of x dx? Now here's the thing, even though we cannot integrate the inverse cosine of x itself, but we can try to differentiate it. So this is why we use integration by parts, because it is related to differentiation. So to use integration by parts, we have let this equal have the differential column and integral column, and then I will have the plus minus right here. Now, as I said like just now, even though we cannot integrate inverse cosine of x itself, but we can try to differentiate it. So we will have the inverse cosine of x right here. What about integral? Now, integration by parts means it's a method to solve an integral where you have a multiplication between two functions, right? So we got inverse cosine of x, and the other one is going to be 1, and then when we integrate we get x, right? But what about inverse cosine of x? So how are we going to find the derivative of inverse cosine of x? Now, so here's how we do it. So I will let y equal to inverse cosine of x. Then x is equal to cosine of y. And then by using the concept of implicit differentiation, so I will have this as the derivative of this equation with respect to x. So the derivative of x is equal to 1. And then derivative of cosine of y is equal to negative sine of y. And remember we are dealing with the derivative with respect to x, not y, which means the y, it could be something that it's a function that relates to x. Because of that, we have to apply the chain rule. So the derivative of cosine of y with respect to x is going to equal to negative times sine of y times dy over dx, because of the chain rule. And then we are going to take the sine of y down here in order to get dy over dx. So dy over dx is going to equal to negative 1 over sine of y. And then sine of y, it is equal to negative 1 over the square root of 1 minus cosine square of y, right? Because you can try to apply the trigonometric identity, which is sine square of x plus sine square of y is equal to 1. But since we're dealing with y, you just replace the x with y. And then now here's the thing, cosine of y is equal to x. Did you remember this? Cosine of y is equal to x. So this thing is going to be equal to negative 1 over square root of 1 minus x square. So the derivative of inverse cosine of x is equal to negative 1 over the square root of 1 minus x square. So to do this, I have negative 1 over square root of 1 minus x square, and then we are multiply x with inverse cosine of x. So this integral is equal to x times inverse cosine of x minus, and then because we got minus sign, times the row. So we got negative times negative, so we will have positive. So x over 1 minus x squared dx, and then don't forget the integral. I almost forgot the integral sign. And then we are going to solve this. Apparently this is really simple because you can just apply simple u substitution. So you do this for yourself. So this is equal to inverse cosine of x. And yeah, I almost forget another thing. Because we are dealing with indefinite integral, we have to put the lower limit and upper limit. So we wait. So now, we are solving this integral. So I will plus the integral of this. Now I will using u substitution, let u equal to 1 minus sine square, and then du is equal to negative 2x dx. So u is equal to 1 minus x square, and then du is equal to negative 2x dx. Then dx is equal to negative 1 over 2x du. So the integral from where to where? Let's see. Now the integral from now, since we are applying u substitution, then we can apply. Since we apply the substitution, so we can just take the value of x of the lower and upper limit to the respective u value. So as x is equal to 1, u is equal to 1. X is equal to negative 1, u is equal to 0, and then this is equal to 0 also. And then we are going to do some substitution. So I will have 1 over 2 times square root of u, and then don't forget negative du. And then now here's the thing. Now when we have any kind of function in the integrand, if the lower limit and the upper limit is equal to each other, then I can conclude that this thing is equal to 0. So we are just focusing on here. So now, so this integral is equal to x times inverse cosine of x from negative 1 to 1. So this thing is equal to, so we will plug the upper limit first, then we will do the lower limit. So x is equal to 1. So which is 1 times inverse cosine of 1 minus negative 1 times inverse cosine of negative 1. So inverse cosine of 1 is going to be equal to 0, so this thing cancels out because it's going to be equal to 0. And then negative become positive. 1 times inverse cosine of negative 1, that is equal to pi. So what I can conclude is the integral of inverse cosine of x from negative 1 to 1 is equal to pi. I hope you guys learned something new from this video, and if you enjoyed the video, leave a like and subscribe to my channel for more upcoming videos, and I will see you guys next time.